What we're going to talk about in this lecture is how do we factor things that don't necessarily factor using the GCF. So we're going to start with a little bit of a review. What I want you to do right now is to just take a look at these two problems here and multiply those two sets of binomials together. So multiply x plus 4 times x plus 6, and then multiply x minus 3 times x minus 5. Pause the video right now and take a second to get those products. All right, so what we hopefully would have gotten and remembered from last time we did this stuff is, let me just get my pen going here, there it is. It's kind of our circles and rainbows. This is one method. You might have used the table method. That would have given us x squared. If we multiply x times 6 and x times 4, those are like terms, so we're going to add those together and get 10x. And then we're going to multiply 4 times 6 and get 24. Sorry, handwriting's a little sloppy. Right? And this is just a little cleaned up version of what I just did right there. Same thing over here. If I take, I won't even try to do the circles and rainbows on this one. If we look at that and say distribute the x and then distribute the -3, when we simplify this one, when we multiply this one, we should get x squared because it's x times x. We'll have a -5x and a -3x, giving us a total of -8x. And then we're going to multiply -3 times -5 and get positive 15. Now, what I want you to notice here is when we looked at these binomials here, in this first one, we had a +4 and a +6. And then look what we wound up with. We wound up with something with a +10 and a +24. Right? Well, that's interesting. And then when we are over here, when we multiplied -3 and -5, we wound up with a -8 and a +15. So it looks to me when we multiplied these binomials and the answers that we got were the middle term, that x term in both, was the sum of whatever was in the binomial, and the last term was the product. Well, that's going to help us factor these trinomials, because if we look at these trinomials, x squared plus 10x plus 24, or x squared minus 8x plus 15, there's no way we can factor it using the GCF. But these are definitely ones that we're going to want to be able to factor later on, right? So to factor a trinomial in the form x squared plus bx plus c, which is, and it is important to note that the coefficient of the x squared is 1. There's no number in front of the x squared. This is all for that type of problem. But whatever's in front of the x squared is 1 in this case. We're going to talk about it when it's not 1 later. Whatever is in front of the x is b, and whatever number's out by itself is the constant, or c. What we're doing when the big idea as to how to factor these trinomials is, what we want to do is we want to find the factors of c. We want to find the numbers that multiply to give you that number and add together to give you that number. Right? Just like we had before. I think we had x squared plus 10x plus 24, right? Well, we got that by looking at x plus 4 times x plus 6, right? So if we are being asked to factor that one, we would have to look at the numbers, say, okay, I need the numbers that multiply together to give me 24 and add together to give me 10. Let's expand this out a little further, because if we can look at these binomials and see what's going on, we can actually do a lot of this process without doing really any computations whatsoever. It's kind of nice. So what we want to remember is if C is positive, if this number here is positive, or if the operation is addition in the trinomial, then both of the factors here, both of these binomials, will have the same operation. Because how did we get a positive when we multiply them together? Well, they're the same. So if in the trinomial, the last operation, or the second operation, is addition, it means in our binomial, both of the operations are going to be the same. They're either both going to be addition or both be subtraction. We look at the previous example, the previous slide, we had a subtraction and a subtraction in our binomials. To take that one step further, if we know that this is a positive, if we know that that's a positive, then we look at the first operation rather. The first, if this is addition, when this is addition as well, it means both of the factors will be positive. That's the example we're looking at here. We're looking at the second operation is addition. So then you look at the first one and say, okay, now I know both of them are going to be addition. If we turn around and say if B is negative, right, this is what we had before. We had, I think we had this, right? This is a situation where the second operation is addition. So we know that this is going to factor to two binomials. We know they're both x because that's how we get that first one. X, if it's just x squared, we know it's x and x. Then we knew this was going to be subtraction and this was going to be subtraction. And that's 3 and 5. Right? So there's a lot you can tell just by looking at the trinomial that you're trying to factor. Start with that second operation. If the second operation is addition, then you know both of the operations in the binomials are going to be the same, and they're both going to be whatever that first operation is. Oh, wrong way. Sorry. If C is negative, then one is going to be positive and the other is going to be negative, right? So 10x squared minus 3x minus 10. Right? So we're going to look at this and say, all right, well, how did I get to a negative 10 here? Well, if I'm using the distributive, and I know those are both x, I know one is going to be addition and one's going to be positive because I got a negative 10 by multiplying a positive and a negative. Then we look at it and take it one step further and say, okay, I still am looking for the numbers that multiply together to give you this. So I'm looking for the numbers that multiply together to give you a negative 10 and add together to give you a negative 3. Well, I know 5 and 2 multiply together to give me 10. And since this number is negative, I know that my 5 is going to be negative and my 2 is going to be positive because negative 5 plus 2 is negative 3. Positive 2 plus negative 5 is 10. There we have it. So just a couple of examples here. Again, so I'm looking at this and saying, okay, here's a trinomial. It's x squared plus 13x plus 36. There's no GCF, so I'm going to have to factor this a different way. I'm going to see if I can get it to work as the product of two binomials. I'm going to set up my binomials here. Well, if it's just x squared as the first term, I know that this is going to be x and this is going to be x. All right, so far so good. I've accounted for this. I look at this operation here is addition, meaning I know both of these operations are going to be the same because I multiplied two things together and got a positive. So it's either going to be an addition or subtraction and subtraction. Well, to determine which one it is, I'm going to look at this and say, that's addition, so both of them are going to be addition. Then I'm just asking what numbers multiply together to give you 36 and add together to give you 13. That would be 4 and 9. So the factored version of x squared plus 13x plus 36 is x plus 4 times x plus 9. If I'm looking at this one here, this trinomial, again, no GCF, nothing I can take out of all of them beyond 1, which doesn't really help us. But it does have x squared in the, just x squared at the beginning, so it's going to be x squared, x and x. But now I'm looking at a subtraction sign here. So I know one's going to be addition, one's going to be subtraction. Again, I've done no math here. I've really just looked at it and said, oh, all right, well, that's subtraction, so I know I'm going to have a plus and a minus. So I'm looking for the numbers that multiply together to give you -8 and add together to give you +2. Well, since this one is positive, I'm going to say, all right, 4 and -2. 4 times -2 gives me -8, and a 4 is the positive. Right? Now again, all of these, this continues to be a factoring situation where we haven't really done anything with it yet, but we will. And it's just important that we get to be able to do this, to get this trinomial to this product. All right? We're going to spend plenty of time going over this in class. This is just a first pass of what I wanted you to take a look at. All right? There's a worksheet that's going to follow this, so just give that a go, and let me know if you have any questions. Hope this helped.